The Arctic is one of the coldest places on Earth. It's warming faster than almost anywhere else at 3 to 4 times the global average. But here's the mystery. Climate models haven't been able to explain why this rapid warming is happening until now. At Kyushu University, graduate student Momoka Nakanishi and her advisor, Dr. Takuro Michibata, believe they've uncovered a major part of the puzzle, and it all comes down to clouds. In the Arctic, the skies are often filled with mixed phase clouds. These are clouds that contain both ice crystals and supercooled liquid water droplets. In summer, when the Arctic sun never sets, these clouds act like a parasol, reflecting sunlight and cooling the surface. But in the long sunless Arctic winter, these clouds flip their role. They become a blanket, trapping heat and sending it back to the ground. But not all clouds trap heat equally. The key is in the ratio of ice to liquid inside the clouds. The more liquid water, the more heat they trap. And here's the problem. Most climate models get this ratio wrong. Nakanishi and Michibata analyzed 30 climate models and compared them to satellite observations over the past decade. They found that 21 of the 30 models overestimated the amount of ice in winter clouds. That means the models are underestimating how much heat these clouds are trapping. And that's why they can't fully explain the current warming. But there's a twist. These same models that underestimate today's warming actually overestimate future warming. Why? Because of something called cloud emissivity feedback. As the Arctic warms, clouds naturally shift from mostly ice to mostly liquid, which enhances their heat-trapping ability. This creates a positive feedback loop, warming the region even more. But this effect has a limit. Once clouds are rich enough in liquid, they behave like black bodies, absorbing and re-emitting all heat efficiently. At that point, more warming doesn't change much. Yet, since many models think today's clouds still have a lot of ice, they assume this shift is still ahead and well over-predict future warming. This new research offers more than just answers. It offers solutions. By correcting the ice-to-liquid ratio in climate models, we can create more accurate forecasts, not only for the Arctic, but for weather patterns across the globe. Because what happens in the Arctic doesn't stay in the Arctic. The biggest uncertainty in our forecasts is due to clouds. Fixing these models is essential, not just for the Arctic, but for understanding climate change worldwide. Thanks for watching.